Let's now take a look at the second example, which we now try to move to the more interesting case about reference type. And we're going to follow similar logic. Let's see what's going to happen. Okay. And we still got this util clause, but we're going to focus on this method only. Reassign ref. Let's see. Let me circle box it just to keep us focused. So this is the method that we want to take a look. Reassign ref. And to be more specific, we want to reassign Q, the parameter, by MP, another reference, right? Similar to when we try to reassign the J, which is a parameter, by some other value. We're trying to do something similar, but this time, are we going to create any change to the arguments? That's the question, right? Let's take a look. And I also include the point clause in case that'll be useful if it is. Otherwise, we can ignore that. Let's now try to trace the code. Okay, let's go line by line. First line, we just create the util objects. That's easy, but it has no attributes, so we don't bother drawing that. And we got another class, another line, which will be creating a point objects P with X and Y being 3 and 4. Okay, let's do that. So P will point to an object of type points over here. And we know that every point has two attributes, X and Y. So that will determine its structure, right? That's something we keep emphasizing. And hopefully by this point, you will know how to visualize objects quite comfortably. That's really important skill to pick up. X and Y, and then 3 and 4. Okay, let me just say 3 and 4 over here. All right. And then for the illustration purpose, I'm just using another reference over here to show to you. Okay, I'll explain how to interpret that. But let's now do this first. We declare point, just another variable, so reference before. So before we try to execute this particular method, right, before we do that, I want to record what P really is. Okay, so P is actually pointing to this particular object. I just want to make a reference because potentially I might be able to reassign P into something else. I want to make sure. If I really reassign that, it will be different from the original reference before executing the method. That's my intention. But well, visualize to you. Okay, so this one here. Ref before. Let me just ref of P before. So what should that be? It will just be pointing to wherever P is pointing to, right? So that's assigned to this value here. So ref of P before. Okay, it's simply pointing to wherever P is pointing to, right? That one's also easy. And let's now try to execute this method over here. And we definitely got to apply the principle of call by value. Let's see what's going to happen. So this is the arguments. This is the parameter. And when we try to manipulate call by value, what's going to happen behind the scene? Let's now just remind ourselves. So what's going to happen is, let me just draw this line over here and call by value. Okay, let me just put it over here, right? Call by value. Okay, what's going to happen? Is it going to be P? The P is the argument here, and Q is the parameter over here. Is it going to be P is assigned to Q, or Q is assigned to P? It's not both. It's only exactly one option. It should be parameter is assigned to the arguments, right? Always remember the principle. It's so important. So it's going to be Q is assigned to P, right? So this is a call by value that you have to keep in mind, right? Let me highlight it over here. Okay, Q is assigned to P. Let's now execute it. So Q is assigned to P. So that means we're going to declare some variable Q. And Q is simply going to point to wherever the argument P is pointing to, right? If you really want, I can even include here. So the P here is really the arguments, and the Q is really the param. Okay, just for clarity. Okay, let's now try to execute the method over here, line by line. We are just creating just another points. Let me use a different color here. How about just blue? We are really creating this new point objects, completely different objects. Let's now do that. So it's going to be MP. So MP, new points, is pointing to another point object over here. Okay. I'm running out of space, but hopefully still legible to you. Okay, so the point is going to be 6 and 8. So x and also y. Okay, let me use a different color just to emphasize 6 and 8. 6 and 8. Okay, so that's a new point we are creating. Now here is a question. So this is so critical, so I want to write it out to you. When I try to do this line, let me use pink. When I try to do Q is assigned to MP. Okay, so the question is, let me put it over here. Well, executing this line, reassign or redirect arguments P. Diagrammatically, I'm asking, when I try to reassign the Q, which is a parameter, will I at the same time also reassign P, whose original address was simply copy to Q, right? Would I also reassign P? That's the question. It's a very common confusion about call by value in the context of reference type. Okay, let me highlight the question again, and you really want to think about this question yourself as well. Okay, let me rephrase it again. Okay, let me just repeat the question again. Given that P is going to be copied over to Q, diagrammatically P and Q will point to the same objects. That's how the call by value work behind the scene. So now if I try to redirect Q into MP, so I want to redirect Q into MP, will that as well redirect P into MP? So that's a question. The answer is no, because here, according to the variable assignments over here, every variable assignment is simply just going to copy the value for just one single variable. And here, which variable are we changing? We're only changing the Q. That's the only variable being changed. That's the only variable being reassigned. Any others is simply not going to be affected. The only variable being reassigned. In that case, we're going to reassign Q. If you don't mind, let me use a different color, maybe purple. So we're going to reassign Q into MP. So Q, rather than pointing to over here, it is going to point to MP. Whereas you can see P over here stay the same because P does not appear on the left-hand side of the variable, right? So far, so good. Okay. So now after the method call is done, so P, you can think about currently P is pointing to still wherever reference of P before is pointing to. That means its reference has not changed. So that's why I'm introducing this variable over here. All right. Let's now try to do some assertions after that. So assert true. P is assigned to reference of P before. That's going to check, right? So that means P has not been reassigned. Has not been reassigned. Okay, should be ed, reassigned by the method. Which method? This method over here, which intends to really reassign the parameter, but they're separate copies, so that's why they wouldn't be reassigned at the same time. Only the parameter, but not the arguments. And next line, and then we say p dot get x will be 3, and p dot get y will be 4. That will also pass, because you can see p is here, dot get x, get y will be 3 and 4. So they will pass, right? So all these will simply just pass. All right, so that's about the second example. You can see this example here. Let me recap. We are trying to pass a reference type arguments whose address will be copied because of call by value into the parameter value Q. And we are trying to reassign the parameter into some other object reference. But this is not going to impact the original argument because they are simply just different variables. So reassigning one is not going to impact the other. So we are still applying what we learned as the basic principle of aliasing or object variable copying that we learned before, right? Okay.